Oh, I forgot to do a sign-in sheet. So, let me see. Okay, I forgot to do a sign-in sheet, so I'm just passing around sheet of paper for you to put your name. Second thing I'm doing is I'm passing around a English to metric table. Just take one and pass it along. Okay, some just quick announcements. I apologize. And I did receive a bunch of emails and I apologize for not answering them. But basically related to the quiz. The quiz was supposed to be today. And if you looked at the folder, it said Monday, but then it had today's date. But if you looked at your syllabus, it was supposed to be today. So it's now been corrected, but the quiz is today. I do that so that you have a chance to turn in your homework. You can come in on Tuesday, ask me some questions before the quiz. The quiz is on active. You'll have 30 minutes to do the quiz. It is going to be over the material from last week. You get one shot on each question. Unlike homework where you get a couple, you only get one shot on each question on quizzes. So the quiz is now active and live. And again, I apologize for the incorrect information on Blackboard. Some other little details. Number one, in addition to the homeworks or the quiz today, the homework that will be due tomorrow, you will have 2 math, chemistry, and puzzles. These are those math puzzles or math, although the math, chemistry, and puzzles that are due. And I told you they would be due when we got to that material, because I couldn't guarantee when they would be due. It depended upon where we got to that material. So you do have 2. One is English to metric, one is metric to metric conversions. They are due by Monday of next week, I believe is what I put. So you have an entire week to get them done. And then you also have your density lab. There's 3 egg puzzles associated with this week's density lab. There's the one for density of an irregular solid, one for the density of liquids, and one for the density of gases. So all 3 of those are posted, and I will be getting your density lab posted sometime this afternoon. But I want to do some edits to it to make sure it is up to date as best as I can. Because again, I'm having to redo all the labs simply because we transitioned to COVID labs, and now we're transitioning back from COVID labs, and I've got to make sure that the labs are accurate before I hand them out to you. So it's taking me a little bit longer to get the lab together than it would normally, simply because I have to make sure that it is ready to go. Any questions before I get started into today? What we're going to be doing today is we're going to be doing dimensional analysis. And then on Thursday, we finally get to start getting into chemistry, because we'll start getting into the periodic table and the elements of the periodic table. But today it is all about dimensional analysis. Folks, dimensional analysis is simply a process. You've been doing dimensional analysis probably the majority of your life. If I asked you how many eggs were in 3 dozen eggs, what would you say? 36. Now, you were able to come up with that number because you know that there are 12 eggs in 1 dozen eggs. And so when you did this, you would go, okay, if I start with 3 dozen eggs, then I would multiply that by 12 eggs over 1 dozen eggs, where the dozen eggs cancels out. And when you get through with that multiplication, you get 36 eggs. Now, you probably didn't do it exactly like that in your head. You just know there's 12 in a dozen. 12 times 3 is 36. But essentially, this is what you were doing. If I asked you, okay, I have 3.5 feet. How many inches is that? You would go, okay, well, I know that there's 12 inches in a foot. If I have 3.5 feet with 12 inches per foot, that is 42 inches. You've been doing dimensional analysis all of your life. It is a process. That's all. So let's talk about the process of dimensional analysis. Because if you understand the process of dimensional analysis, you can use, wrong one. I could ask you how many grains are in a scruple. And most likely you've never heard of scruples and grains. It is an apothecary measurement. But if you know the process of dimensional analysis, you could get there. So let's talk about what the process is first. So the very first thing you do is identify what you were given. The next thing you're doing is identify what you want. The third thing you do is identify possible conversion factors. And as we're doing the possible conversion factors, what we're looking for is a conversion factor that has the unit that we're starting with, or the unit that we want, or both if possible. Now, as you do this third step, folks, you may get every single conversion factor you need, or you may not. But you start by identifying possible conversion factors based off of the units that you want to do, that you start with, and the unit that you want. Then we start, we develop the problem. Number one, or part A, is we're going to start with a quantity given. And I do say a quantity given because in a problem, you may be given multiple pieces of information. Now, when we're looking at a quantity given to identify, what we're looking for is we're going to ideally begin with a value that has only one unit. Associated with it. Now, folks, this may not always be possible, but I would say probably about 90% of the time it is possible. So if you're given multiple pieces of information, you're looking for a value that has a single unit associated with it. Then we start to set up our problem. And as we set up the problem, we do so by adding a conversion factor to the setup in a manner where the unit in the previous part is canceled out by the denominator. Basically, if you pay attention to the key to conversions is really paying attention to your units. You watch your units cancel out until you get to the desired unit. Then you perform the calculation. Whoops. And you try to do a quick check to see if it makes sense. That's the process. And if you follow the process, you should be able to perform whatever conversion you want to perform. So let me just show you what I did. I mean, I told you that I had, in the case of this first one, I had 3 dozen eggs. Well, I didn't do, let's see. Told you I had 3 dozen eggs. So I identified my starting quantity, and I wanted to convert that into actual eggs. So I identified what I wanted. I identified what was given. I identified what I wanted. I then found a conversion factor that allowed me to do it. I then started setting up the problem, and I always start the problem with the piece of information that was given, the 3 dozen eggs. And then the specific conversion factor, I looked at it and I'm going, okay, so I need to get rid of dozen eggs. So that's why of the conversion factor, I put the dozen eggs piece on the bottom so that it would automatically cancel. These are obviously simple, straightforward ones, but I wanted to show to you that you've been doing this method. I'm just writing it out and explaining the method. Because I notice as time goes on, students get lost in the minutia. They want to go, okay, I'm going to do this problem, but then they can't figure out where to begin. This is trying to help you outline where to begin and the general process. Because if you follow the general process, you should be okay as long as you've got your versions. So what we're going to be doing today is we are going to be doing lots of conversions. This process, folks, is not only going to carry in from this English to metric conversions that we'll be doing, metric to metric conversions that we'll be doing. We'll also use this process later in the semester when we start doing stoichiometry. Stoichiometry is nothing more than dimensional analysis. It's just when we get to stoichiometry, we're specifically talking about chemicals. And there's specific locations where we find our conversion factors rather than on a table. So the process is going to come back multiple times throughout the semester. Okay, so let us just get into some conversions. So the very first thing I'm going to do is I'm going to convert 261 grams into kilograms. Now, what I'm trying to do, the very first thing I'm doing is like, okay, do I use that metric conversion table that I gave you at the end of last week, where I told you about tera and mega and kilo and centi and so on and so forth? Do I use that table, or do I go to a table that you have to be given to find the conversion factor? Now, the way you're going to know which piece to use is by asking the question, do the units have something in common? Do the units have a common word? As long as they have a common word, that means you're using your metric conversions. So gram to kilogram, they both have the term gram. That means you've got to use those metric conversions. Now, the conversion factor is that there is 1 times 10 to the 3rd grams is equal to a kilogram. Or you can say that there's 1,000 grams in 1 kilogram. Now, going in, we always start our problem with a piece of information given. So we're going to start with the 262 grams. In setting up our conversion, we want the grams to cancel out. So we're going to take the gram portion of this conversion factor and place it into the denominator. By taking the gram portion and placing it in the denominator, the grams cancel out and you're left with your kilograms. And when you do this calculation, you'll get 0.262 kilograms. Because kilogram will be the only unit left over. Now, folks, if you do want to think about significant digits, our very first value has 3 significant figures, because it is, they're all non-zero digits. Your metric conversion factors are exact quantities. So they have an infinite number of significant digits. So that piece isn't going to matter. It's only going to matter with what you started with, which was the 262. So our answer has to have 3 significant digits, and it does if it's 0.262. Questions? Let's look at another example. Let's go 498.82 centigrams into milligrams. Right off the bat, I noticed that they have the term gram in common. Because they have the term gram in common, that means that we're going to be using our metric prefix conversion factors. Now, if you look at that table I gave you of metric prefix conversion factors, one possible, the centigram is 1 times 10 to the minus 2 grams is equal to a centigram. And the milligram is 1 times 10 to the minus 3 grams is equal to 1 milligram. Now, folks, you may know a different version of this, and that's fine. I'm using the one that I gave you on Thursday. I'm trying to be consistent, in other words, because folks, I use a different one also. Often I go between different styles of this, but I'm trying to be consistent. Okay, and why did I choose these conversion factors? I chose it so that I needed centigrams. One of them has centigrams. I needed milligrams. One of them has milligrams. That's why I chose those conversion factors. Now, I begin with the piece of information that I was given. 498.82 centigrams. My first conversion factor is going to contain centigrams. So I'm looking at that conversion factor, and the unit associated with it is 1 centigram is 1 times 10 to the minus 2 grams. The centigrams will cancel out, leaving grams. I still needed to get it to milligrams. So I'm going to use the other conversion factor. The 1 times 10 to the minus 3 grams is going to go in the denominator with 1 milligram in the numerator. The 1 times 10 to the minus 3 grams had to go in the denominator so that the units would cancel, leaving milligrams. So if I did this correct in my head, that's going to be 4,988.2 milligrams. I'm going to double check my math. And that is correct. I just want to double check my math out that I did in my head. Questions so far? As I said, it's all the same process. Yes. You have to memorize the ones I gave you on Thursday. If it is an English to metric conversion factor other than like time or 12 inches in a foot, something that I expect you to pretty much know, I will give it to you. But the ones I gave you on Thursday, you have to have memorized for your exams. All semester long. No ifs, ands, or buts. Okay, so let's look at another example, because this is going to start getting a little bit more challenging. We're going to convert 5.93 centimeters cubed into meters cubed. Now, folks, if I actually, again, they had a term in common. They had meters in common. So we are looking at the metric prefix conversions. Now, when I go look at the metric prefix conversions, I get 1 times 10 to the minus 2 meters is equal to 1 centimeter. But you have to note that I am dealing with centimeters cubed, not centimeters to the 1. So I cannot use this conversion factor as it stands, because the units would not cancel out, because you've got to have centimeters cubed and meters cubed. So how do you deal with this situation? What you have to do is you have to cube the entire conversion factor. So in other words, that's going to be 1 times 10 to the minus 2 cubed, meter cubed is equal to 1 cubed centimeter cubed. Now, when you do that, this becomes 1 times 10 to the minus 6 meters cubed is equal to 1 centimeter cubed. Now that I have the correct unit, I can actually do the math. So I have the 5.93. Oh, come on. Centimeters cubed. And I know that 1 centimeter cubed is equal to 1 times 10 to the minus 6 meters cubed. The centimeter cubed was placed in the denominator so that the unit would cancel. And when you complete this calculation, you get 5.93 times 10 to the minus 6 meters cubed. Questions? Yes.
Is that a negative N? It looks like it.
No, that's not supposed to be, that's just a dot. I don't know, I'm guessing it was wrote or there's something on my screen. I see what you're talking about, but I couldn't from the single. Other questions? So let's look at this problem, and we're going to be using significant digits and everything we're just figuring out here. One sphere has a radius of 5.10 centimeters. Another has a radius of 5.00 centimeters. What is the difference in volume between the two spheres? We do need to give the answer. To the correct number of significant digits. And the volume of a sphere is 4/3 pi r cubed. And so, and basically R stands for radius. Okay, folks, looking at the pieces of information that we have been given, we know that one sphere is 5.10 centimeters. And we know that the other sphere is 5.00 centimeters. The first thing we need to do is calculate the volume for each of these. So the volume for the first sphere is going to be 4/3 pi times 5.10 centimeters cubed. Now, keep in mind what I just told you about how to cube things. You got to not only cube the unit, but cube the value. So in reality, this volume is equal to 4/3 pi times the 5.10 cubed centimeters cubed. When you key this in, you get a volume equal to 555.64, oops, 647 centimeters cubed. For the other one, the volume would be equal 4/3 pi times 5.00 cubed centimeters cubed. And that answer comes out to be 523.599 centimeters cubed. It asks for the difference in the volume, which means it's going to be the 555.647 centimeters cubed minus the 523.599 centimeters cubed. That is supposed to be a 5. When you key this in using the your significant digits, we would record our answer. It comes out as 32.048 centimeters cubed. Because we're not allowed to keep any decimal places, we would simply call it 32 centimeters cubed. Because this is addition, when you're talking about the difference, you're talking about addition and subtraction. And with addition and subtraction, it is the number of decimal places that you focus on. Because this first value had only 3 significant, the 5.10 only had 3 significant digits, we were only allowed 3 significant digits. Because the second one only had 3 significant digits, we were only allowed 3 significant digits there. But when you talk about the math, you'll notice that I subscripted all the decimals. That's because those were insignificant digits, but I didn't want to round until the end. And then those disappeared because they weren't significant to begin with. Because only the decimal places matter. Questions? Okay. let's look at another problem. Okay, Sally Leadfoot was pulled over on her way from Syracuse to Ithaca by an officer claiming she was speeding. The speed limit that was posted is 65 miles per hour, and Sally had traveled 97 kilometers in 102 minutes. How fast was Sally's average speed, and did she deserve the ticket? Okay, so a speed is known as a rate. And a rate is equal to distance over time. So to be able to determine if Sally was going over the speed limit, we have to get her distance over time. Now, let's look at everything that we were given. We were given 65 miles per hour as the posted speed limit. We were told she was going 97 kilometers in 102 minutes. Now, because I need distance over time, what I'm going to do is I'm going to convert this kilometers into miles so that it matches the speed limit sign. And I'm going to convert the minutes into hours so it matches the speed limit sign. Now, I'm looking at this, and for the first time, I have kilometers, I have miles. There is no term in common. Because there is no term in common, that's when you go to your metric to English to metric conversion table or a conversion table, or look for it in the problem. It will be in one of those places. So when there's nothing in common word-wise, you've got to go to a table to find it or look in your problem. So in this particular table, let's see, I find 1 mile is equal to 1.6 kilometers. So 97 kilometers will go in the numerator. Now, as far as my conversion factor, I'm going to place the 1.6 kilometers in the denominator and the 1 mile in the numerator. I do so that my units will cancel, leaving me nothing but miles. So 97 divided by 1.6 is 60.625 miles. For our time, we need to convert that from minutes to hours. And you should know your time, hopefully, for all of your life. I won't give you time. 60 minutes in an hour. So we're going to divide that by 60 minutes is 1 hour. And that comes out to be 1.70 hours. Now, folks, you may be asking me why the significant digits that I did. If you look at your table, it tells you that all of those numbers on that table were approximate, meaning that there's probably a lot more decimal places I could go to. So I'm focusing on what I know for certain. Anyhow, oops. Now that we have it in miles and we have it in hours, we can actually do our division. And when we do so, if I can complete that, you get that they were only going 35.66 miles per hour, or in other words, 36 miles per hour. The ticket is not deserved. Now, the only problem with this is obviously, as you may consider it, this would be an average. And police officers look at what you're doing at that particular moment. But so we don't know if it was deserved at the moment. But anyhow, if we look at the average, it wasn't. Questions? Folks, you may go, okay, you know, a lot of what I've been doing is hopefully fairly straightforward. But what we're going to do now is I'm going to get out of this, and where am I? Yes.
So in that one, we only get 2 sig digits in the front. Is that because our large numbers?
Yes. Okay, so what I want to do now is go to some of the ways you may see a problem. Okay. So this is a active learning problem. Stephen is to get 7.0 milligrams per hour of continuous morphine sulfate infusion. The solution is prepared as a 125 milligram morphine in 250.0 milliliters dextrose solution, otherwise known as D5W. Calculate the infusion rate in milliliters per hour needed to deliver the correct drug dosage. Okay. So let's talk about what we have here. And let's see if I can write on this. I hope I can. I have, nope, it's not going to let me. Yeah, that's see if I can find my buttons. Okay, so what we have is we have 7.00 milligrams per hour. And we are told that we have 125 milligrams of morphine per 250.0 milliliters dextrose. Now, folks, what we really need to do is take a moment to look at the information we were given. When we say we have 7.00 milligrams per hour, what that really means is you have 7.00 milligrams of, in this case, the morphine solution per 1 hour of time. So in other words, I rewrite the unit so that it is separated out. And ultimately we want milliliters per hour. So that's going to be our goal. So what we're going to need to do is we're going to need to take and convert that milligrams to milliliters. Because we already have, if you look at this, we already have the hour component. So we need to convert the milligrams to milliliters to get this correct. So we're going to take this 7.00 milligrams of morphine per 1 hour. That is going to be our starting point. Like I said, a lot of times I do try to get it where I only have 1 unit, but sometimes it's just not a feasible possibility. Our conversion factor, we're going to need to put the milligrams in the denominator. So when you have a fraction, it can either be written the way it is, or you can flip the entire fraction over. And in this case, I need to flip the entire conversion factor over. So my milligrams of morphine will cancel out. And you will notice that you are now left with the units they desired. You've got milliliters over hours. So 7 times 250 divided by the 125 is going to be 14.0 milliliters per hour of our solution. Yes. No, only last week's information is on the quiz, not this week's information. There are some more so in practicing this, there are problems that are in the optional homework. And then if that's not enough problems, you can see me and I'll come up with more for you. Yes, the optional homework is in this week's or is in, well, it's in both folders, last week and this week's folder. And it's in the folder that says optional homework and keys. So you'll find an optional homework that's blank, and then you're going to find the same homework with the answer key. And I do show my work on the answer keys. Let's look at another problem. Let's look at this one. Tracy is receiving Lanoxin every 8 hours. She weighs 71 kilograms. The dose range for this drug is 0.030 to 0.6 or 060 milligrams per kilogram every day. What is the maximum safe dose in milligrams that you should deliver every 8 hours? So maximum would be this number that we're going to be paying attention. I got to take a picture again. There we go. So if we're looking at the maximum, we're going to be paying attention to the 0.060 milligrams per kilogram. Now, what does that milligrams per kilogram mean? Think about looking at the problem. What does the milligrams per kilogram mean? You've got to really look at this problem and understand what you're looking at. It means you have 0.060 milligrams of the Lanoxin per every 1 kilogram of body weight. Now, there is another piece to that. That says every day. So technically, this is a conversion factor to 1 day. We also know that she weighs 71 kilograms, and we're looking at how much to give her in 8 hours. Well, the very first thing I would do is go, okay, that is, let's see. So if I wanted to get this dosage correct, 0.060 milligrams of Lanoxin per 1 kilogram body weight per day, I would take and I would convert that into hours. So there's 24 hours in 1 day. The day would go away. So 0.060, let's see, I always have to do this. That's over 1, so flip it. So 0.006 divided by 24. So that means we're talking about 0.0025 milligrams of Lanoxin per 1 kilogram body weight per hour. Now, if you multiply that by the 8 hours, you find you need 0.02, and it would be 0 milligrams lanoxin per 1 kilogram body weight in the 8 hours. For the 8 hours. And I'm sorry, that's not very legible at the top, but it would be for the 8 hours. Now we can multiply that by the 71 kilogram body weight. And you find that the dosage you need to give in that 8 hours is 1.42 milligrams in 8 hours. Every 8 hours. So again, what I had to do is I really had to think about what this meant. That's what makes dosage calculations challenging, is sometimes you got to think about what you're actually talking about. Once I understood what that meant, I knew, okay, I'm only supposed to be using it for 8 hours. So how much would that be? Once I understood how much I needed per in that 8 hours, then I can multiply it by Tracy's body weight in kilograms to figure out how much she as an individual needed, or he as an individual needed. Questions? Oh, hush. Settle. Settle. Folks, there's no perfect way to do these math problems. There is a multitude of ways you can do it. I am showing you the ways I think through things, but that may be, you may think through things a little different. This is how I process things and how I think about things. But when you start getting into dimensional analysis, there are a multitude of ways of thinking of things. When you get into dimensional analysis, while I may put this conversion factor first, you may put it later on. As long as your units are canceling to give the desired result, you'll be okay. As long as your units cancel to give you the desired value, you're going to be okay. Okay, let's look at a different problem. I can come back to dosages if you'd like in a few. I'm trying to do multiple problems here. Hopefully there will be one similar to what you're wanting to do later on. Oops. Ugh. Okay, at any given point or at a given point in its orbit, the moon is 2.4 times 10 to the 5 miles from Earth. How long does it take light from a source on Earth to reach a reflector on the moon and then return to Earth? The speed of light is 3.0 times 10 to the 8 meters per second. So what am I given in this problem? The very first thing I'm given is 2.4 times 10 to the 5th miles. And the other thing that I am given is that it is 3.0 times 10 to the 8 meters per second. And I have been asked, how long does it take? It doesn't specify, it has whether it's supposed to be in seconds, minutes, or whatever. So we're not going to worry about the unit of time. We'll go ahead and use the second since it's already part of the problem. So looking at this, folks, I have two pieces of information here. I have the 2.4 times 10 to the 5th miles, and I also have the speed of light, and I can rewrite the speed of light to be 3.0 times 10 to the 8 meters over 1 second. Now, as I said, it's always best to begin a mathematical calculation with a value that has only one unit associated with it. So it is most ideal to start this calculation with the 2.4 times 10 to the 5th miles. Now, if I'm looking at this carefully, I see, okay, I've got miles, and that's a unit of length, but the unit of length associated with my speed of light is meters. So I'm going to need a conversion factor that allows me to go miles to meters. Because they do not have anything in common, you're going to be looking towards your sheet. And I can go, so when I look towards that sheet, I see the only one I have is 1 mile is equal to 1.6 kilometers. So I found a conversion factor. So let's just say, okay, I'm going to go with it. I have 2.4 times 10 to the 5th miles. I'm going to use my conversion factor that has miles, which is 1 mile is equal to 1.6 kilometers. I place the mile portion in the denominator so that I make sure the unit cancels out and I'm left with kilometers. But kilometers is not meters. So I can't use my speed of light yet because they're not the same unit. But kilometers and meters do have a word in common. Therefore, I need the metric prefix system, which is 1 times 10 to the 3rd meters is equal to 1 kilometer. Looking at that, the 1 kilometer will go into the denominator and the 1 times 10 to the 3rd meters will go into the numerator. The kilometer had to go into the denominator so that the unit would cancel. Now I'm left with meters, which is what I needed to be able to use the speed of light. Currently, my meters are in the numerator, so I need the meters to be in the denominator. So I'm going to have to flip the speed of light. I had to flip the speed of light so that the units would cancel. And now I'm left with time, which I was asked how long. So let's put this in, 2.4 times 10 to the 5 times 1.6 times 1 times 10 to the 3rd divided by 3 times 10 to the 8. I get a value of 1.28 seconds Now, always go back and read your problem and make sure you answer the question. When you looked at this problem, the problem has stuck. Da, 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 da. Go back and look at the problem while I'm trying to figure out why you're misbehaving. There we go. If you look at that problem, it said to reach a reflector on the moon and then return to Earth. What did our answer of 1.28 tell us? It told us how long it took to reach one direction. So to get your answer, you're going to take the 1.28 seconds and multiply by 2 because we've got to come back to Earth. So that comes out to be 2.56 seconds, or in other words, 2.6 seconds. Questions? Always reread your problem and make sure you answer the question. Yes. Oh, you're stretching. Questions for me? Do you want me to work any more problems today, or are you good? I like actually, everything is posted. If you do watch the videos, that means we'll primarily discuss the periodic table a lot on Thursday, and I will discuss and we'll work problems related to atomic number, mass number, protons, neutrons, and electrons instead of, and that way you have lots of things you can look at when you're doing your own homework. Questions for me? Yes. Uh-huh. Yes, please come to my office so I can look at the problem individually. Okay, we're gonna go 7 minutes early because y'all didn't want any more problems today. Come here, Luna. Yes. Sure. Come here, Luna. Come here. Come here, my Luna. Yes, my good girl. Thank you. It's due at 11:59 tonight. And it takes 30 minutes. Once you open it, you got to do it.
But I'm gonna take a second.
Oh, I was just gonna ask you, if I go, 'cause I think I'll be fine this semester. You're teaching me everyone, I understand it,
Oh, yay.
because I didn't have a good foundation, but this is helping. If I want to get time extra for this calculus, do I have to go to a separate facility to get?
Yes, you're going to have to go
Okay.
to the office of.
Because I didn't know if they could do it
OARS.
here, or if I'd have to go to a different, will they do it here? Will they test me for that here?
I don't know.
Okay,
You're going to have to talk to them because I
Okay.
really don't know enough about the process. I'm just
because
told,
I have a place I can do it if I need
Yeah.
to.
go talk to them first. They may tell you, yes, you have to do that. And the reason I'm saying that is I don't know their process. I just get a memo saying this
Hey,
person
yeah,
needs extra time for this.
okay,
And normally that means you're going to take your test over in their facility rather than our facility.
because I just know this semester I'll be fine, but going forward.
Yeah.
I'll probably
You
need it.
definitely want to, if it, because College Chem 2 is much more math intense
Yeah,
than is College Chem 1. So yes, go talk to them because I really don't know the process.
I think we always kept it getting everything situated with my homework and stuff.
Okay.
Just because I'm a freshman and it's a little bit different than high school. So I was wondering if you have any advice on like if they.
Sure. Can you come by my office either today or anytime tomorrow before 3?
Before 3, yes.
Okay. Then come by my office. I'll be in my office today after, well, after 3, from 3 to 4:30. And then tomorrow I'll be there until 3.
Okay, so do you want me to come by today around
It
3?
doesn't, that's fine, whichever works for your schedule. And that way I can actually think about what you're saying
Yes, ma'am.
and help you come up with a plan.
Yes, thank you so much.
You're welcome.
So earlier when we were writing out the conversion factors, you said that 1.6 kilometers to 1 mile is approximate, but then, so is that the approximate like value and the significant digits are still exact?
Technically, no. The approximate value, I should have used the 1.6.
So what do I
It
do
just
about the
works.
significant figures? Make them infinite?
It technically.
Okay. Okay, thank you.
It's okay.
So I remember going in the office and you saying that my active chemistry will show up on Blackboard. It hasn't yet.
Oh, for the homework one? For homework one?
And 2.
I know homework 2 won't, because I did adaptive follow-ups for those that struggled with homework 2. If you didn't struggle, then you didn't have to do it. I'm gonna have to look and see what's going on and contact them, or I may have to post it myself. In the past, I haven't had to, but I may have to.
Exact numbers. Like when we do those, are we supposed to go by those as significant figures